Okay, question 13. And this is the last question of the paper, which means it's going to be a difficult question for sure. This one, yeah, it's certainly not easy, but to be fair, I've seen worse I actually think the previous question was harder. Anyway, part A, it says determine, well, hang on, let me explain the situation. So we have this girl, she's hitting a golf ball, and theta is the angle that, so when she hits the ball, theta is that angle, the angle that let me do that again, the angle that the ball makes with the horizontal, and L is the length that the ball goes. Now, she has discovered that dl d theta, that's the change in length with respect to theta, is this, minus 0.2 theta plus 9. That's not L is equal to this, it's the change in L is equal to this. And it's only true between 35 degrees and 75 degrees. Okay, part A. Determine whether the graph of L against theta is increasing or decreasing at theta equals 150. Okay, so one of the things we definitely need to understand is that a graph, some graph, right? This is not, I'm not drawing this graph or the graph of L against theta or anything, but when a graph is increasing like this, the derivative is positive. So the derivative is positive because the gradient is positive. When the graph is decreasing like this, like down here, it's decreasing, the derivative is negative because it's decreasing. And when it's at a minimum or a maximum, the derivative is 0. That's why we, in order to find the max and the min, we get the derivative equal to 0. But what's important is that the derivative is going to tell us if it's increasing or decreasing, because I don't know what this graph looks like. I don't know what the graph of L against theta, this is L against theta, I don't know what it looks like, but I will be able to tell you if it's increasing or decreasing by finding dl d theta at that point. So I'm going to get dl d theta when theta equals 50 degrees is equal to, you can write that like this if you want, theta equals 50, but I'm just so it's clear, dl d theta when theta equals 50 is equal to minus 2 times 50 plus 9, sorry, not minus 2, minus 0.2, minus 0.2 times 50 plus 9. Now, what's 0.2 times 50? Well, it's 10. You can do that in your calculator if you want, but trust me, it's a tenth. It's 10 because 0.2 is a fifth. A fifth times 50 is 10. So it's negative 10 plus 9. What's negative 10 plus 9? Negative 1. So the derivative when theta equals 50 is minus 1, which means it's negative. If the derivative is negative, therefore, the graph of L against theta is decreasing. You can write, if you want, as dl d theta is negative. Okay, that's the first part. Second part. Sion observes that when the angle is 40 degrees, the ball will travel a horizontal distance of 205.5 meters. Okay, so she's given us 2 bits of information here. Find an expression for the function L of theta. Okay, probably the hard part of this question is realizing what type of question it is. Once you realize it, then to me it's just a kind of a standard familiar question, but it's hidden in a complex golf problem. But what this question is a integration question. It's an integration question where you have to find C, because they give you the derivative and they're asking you to find the function. When you have the derivative and you have to find the function, it's integration. So let's do it down here. dl d theta is equal to negative 0.2 theta plus 9. Now the integral, well, we can say L is equal to the integral of negative 0.2 theta plus 9 d theta. So the integral of this. Now what is the integral of this? Well, the integral, if you remember how to integrate, guys, it's minus 0.2 theta. I'm integrating with respect to theta. So if you're used to dealing with x, it just works the same way. It's theta squared raised to the power by 1 divided by the new power. Plus 9, when you integrate a constant, you get 9 theta. So it's this plus this, and then don't forget plus c. So L is equal to this. Now the initial condition they give us in the question is when the angle is 40 degrees, the horizontal distance is 205.5. So I'm going to write that here. When theta equals, what did I say, 40 degrees, when theta is 40 degrees, L is equal to 205.5. So I just need to sub this in here. So 205.5 equals, and by the way, I could have simplified this, guys. In fact, let's do that now. It's negative 0.1 theta squared plus 9 theta plus c. So this is equal to, let me just move this down a little bit here. This is equal to negative 0.1 theta squared, but theta is 40 now, so it's 40 squared plus 9 times 40 plus c. Then c is equal to, guys, you could do all that with nsolve, I think is the easiest thing to do. So I can go menu, algebra, numerical solve, and we just type this in. 205.5 equals negative 0.1 times 40 squared plus 9 times 40 plus c, and then I do comma c. So I'm solving that equation for c, and c is 5.5. So c is equal to 5.5. Therefore, L of theta, this is what he's asking me for, L of theta is equal to, L of theta is this. I shall go back to this. It's negative 0.1 theta squared plus 9 times theta plus c, but c is 5.5. And that's the answer. Okay, that is paper 1 complete. We have found an expression for the function L of theta. Yeah, hopefully that paper wasn't too bad, and I'll see you guys for paper 2.